from the Department of Biomedical Engineering, SNS College of Technology. Today we are going to discuss about image enhancement. Okay, in this image enhancement, in digital image processing, normally we are using histogram processing. First of all, what do you mean by histogram? Okay, here histogram of R of k, it is equal to nk. Then what is rk? Rk is the kth gray level and nk is the number of pixels in the image having gray level rk. In a normalized histogram, P of rk is equal to nk by n, which gives a clear enhanced image as an output. Okay, this diagram, it shows the dark image, bright image, low contrast and high contrast image here. In histogram equalization, the input image S, it is equal to transformation of R, is the output, it is equal to transformation of R. The R ranges from 0 to 1, and then R, it is equal to inverse transformation of S, it ranges from 0 to 1. Okay, in gray level transformation function, it is both single valued and monotonically increasing also. Okay, next this shows the monotonically increasing function. It's showing how multiple values can map to a single value. And second one, it is a strictly monotonically increasing function. This is a one-to-one mapping both ways. Okay, in histogram, the PDF probability density functions Ps of S, it is equal to 1 by L minus 1, which is derived from Ps of S, it is equal to PR of R, it is multiplied with dr by ds. Okay, the result Sk, it is equal to T of Rk, it is equal to L minus 1 multiplied with summation j equal to 0 to k, PR of Rj, it is equal to L minus 1 summation j equal to 0 to k Ni by n. Here the k value, it is from 0 to L minus 1. Okay, which shows the an arbitrary PDF. A result of applying the transformation in all intensity levels R. Here it shows the resulting intensities S having a uniform PDF. It is independently of the form of PDF of the R's. Okay, this table, it shows the intensity distribution and histogram values for a 3-bit 64x64 digital image. Here Rk from R0 to R7, Nk from 790 to 81 and PR of Rk, it is equal to Nk by M multiplied with N, it ranges from 0.19 to 0.02. Okay, next this one, it shows the illustration of histogram equalization of a 3-bit 8 intensity level image, original histogram, transformation function and an equalized highly enhanced image using histogram. Okay, in this diagram, here in the dark image, light image, high contrast and low contrast image, by using histogram equalization, the highly enhanced images obtained in the result output. For a lighter image, for a darker or any high or low contrast image, the histogram equalization, it gives the same exact enhanced output as a result. Okay, next one we have transformation functions. Here it is obtained from histograms of images. And this curves, it denotes like dark, light, high contrast and low contrast images. And first one in this diagram, it shows a histogram of a 3-bit image. Second one is a specified histogram. Third one is transformation function obtained from the specified histogram and the result of performing histogram specification, and then which is compared with B and D also. In histogram matching, histogram specification, we have Pz of Z as the desired PDF, which is come from S equal to T of R, it is equal to L minus 1 multiplied with integral of 0 to R, PR of W multiplied with dW. Okay, which results Zk, it is equal to G power minus 1, which is multiplied with T of Rk, the k values from 0 to L minus 1. Okay, next one, it shows the graphical interpretation of mapping from RK to SK through transformation of RK. Second one is mapping of ZQ to its corresponding value of VQ through G of Z. And then third one, which shows the inverse mapping from SK to its corresponding values of ZK. In histogram matching, it has obtained the histogram of a given image T of R and pre-compute a mapped value SK for each level RK, obtain the transformation function G from the given PZ of Z. Pre-compute ZK for each value of SK and also map RK to its corresponding level SK, then map level SK to the final level ZK. These are all the steps involved in histogram processing. Here we have taken T of R, RK, PZ of S, PZ of Z, ZK, SK are the elements, and then which shows the histogram of a 3-bit image. Okay, mappings of all the values of SK to its corresponding values of ZK is shown here. This is the application of histogram. Image of the Mars moon, photos taken by NASA's Mars Global Surveyor. The histogram for this one is represented in gray level. And also in histogram, local enhancement also possible. This shows the histogram using a local 3x3 neighborhood. In histogram, we have two types. One is global enhancement and local enhancement also possible. In global, mean and variance are measured over an entire image. For a local enhancement, the local mean and variance are used as the basis for making changes. And finally, histogram, it gives a highly enhanced histogram equalized image as a result of output. Thank you.